There, Billy.
Hello, Grandpa.
You look awful sick. That's why I've came with a story.
Boy, I love action stories.
No. This isn't that kind of story. This is a story of subatomic proportions.
This is gonna be a nerdy story, Grandpa.
No, nothing like that. But it will boggle your mind. It is of something called an atom. What are those little red things floating around them? Those are negatively charged electrons. Atoms are the building block of all matter, or things that have volume and mass. But what we're interested in now is the nucleus. Let's pause the atom for a second, just for a better picture. That's better. Now let's take a look at that nucleus, shall we? Wow. So how did you get to know all this stuff about the atoms, Granddad? Well, when I was young, I was as curious as you. So I constructed a nanoship and veered it onto the nucleus of an atom. No way. Yup. I lashed myself onto the nucleus and attempted to see its applications. Wow. Oh, I can only imagine. What was the surface like? There were two kinds of surfaces. The positive proton, shown here, and the neutral neutron. So wait, there were two kinds of surfaces on the nucleus? Yes, the proton and neutron. No, quite the opposite. I traveled around all the different atoms, categorized by a different number of protons. What's that map? Oh, it's the periodic table, which shows you all the different kind of atoms. It's usually divided onto separate periodic groups. Ah, and you're going slower because there's more protons to see. Right. Wait, what about water? It's not on there. Why isn't it on the periodic table? Well, you have to remember. What exactly is water made out of? Hydrogen and oxygen. Right. These two are compound. This is a compound because it's made out of two different elements. Ah, I see, and that's why water isn't shown on the periodic table. Right. Is this story going to be boring, Grandpa? And so there I found myself, clinging on to a gas version of gold, going up to the great Anunnaki. Wait, why did you heat it up, and what happened to the gold when you heated it up? Oh, that's right. You don't know about the state changes? To render the gold into a gaseous state, I applied heat, or thermal energy, to increase the amount of molecular movement and thermal energy. The opposite of this is to cool it down, to decrease thermal energy and therefore decrease the amount of molecular movement. These two things are usually called heating and cooling, and the process differs between each state. For example, heating a solid to a liquid is called melting, while heating a liquid to a gas is called boiling. These are state changes. On the converse side, cooling a gas to a liquid is called condensing, and cooling a liquid to a solid is called freezing. Oh, that's right. I also heard that there's a special kind of change from a solid to a gas called sublimation. No, it doesn't exist. It's not true. It's not true, okay, Grandpa? In any case, I soon found myself on the highest atom, the fields of Anunnaki, facing the most hideous thing I've ever seen, the face of the antimatter. It doesn't look too scary. It was scary in real life. I could notice all of his physical properties, the properties which distinguished him in a physical change, like the color black, which was the color of his skin. Ah, so is this the action part? No, I challenged him to a battle of wits. You ruin everything, don't you, Grandpa? Let me get on to the story. I had two containers that I wished that one of us would drink out of. One of the containers had a different, you could see the different parts in it, or a heterogeneous, and one you could not, a homogeneous. What did he do? He picked the one which you could not see, and died. Hooray! Yes, well, I think the other reason is because the heterogeneous mixture had a higher viscosity, and therefore he was more reluctant to take it. So it flowed easier? Yes. Actually, a higher viscosity means that it flowed less easier. Ah, I see. So he died though, right? Yes. Not quite. What? He wasn't destroyed. The law of conservation of matter, or mass, states that his remains are still scattered around in the form of energy or mass. But he's dead though, right? Yes, in theory he is. That's right. As you youngsters like to say it, the reactant, or thing that goes into each equation, was my fist, and the product, or outcome, was his death. That's great, Grandpa. That's great, yeah. Good night. Way to ruin the ending.